Okay, so past paper question for quadratics, and this one is about the discriminant. So anytime you see anytime you see roots mentioned, you should be thinking this is quadratics. And anytime it says, anything about real roots, you should be thinking of using the discriminant in some way. Okay, so this is not the same as what we did as our starter in the last lesson. We were just finding what the discriminant was and then stating the nature of the roots and then drawing a graph. We already know the nature of the roots in this case, but what we don't know is one of our values of our a, b and c. We don't know our value of a. That could be a 1, that could be a 2, that could be a -4. We don't know what that value of p is. Right, what we have to do is we have to find the values of p such that this quadratic has no real roots. So we need to remember what no real roots means in terms of b squared minus 4ac. Does that mean it's greater than 0, equal to 0, less than 0? And then we use that knowledge to solve this equation. Okay, so the first line should be no real roots. For no real roots, that means that the discriminant b squared minus 4ac has got to be less than 0. Okay, that would be the graph where, we have the quadratic and it doesn't cut the x-axis. It doesn't have any real roots. It does not cut that x-axis. So that's what we have to state. Using that knowledge that this quadratic has no real roots, that means that the discriminant must be less than 0. Okay, so what we are now going to do is put in our values of a, b, and c and then solve what's going to be an inequation. Okay, so what is the value of a is whatever in front of x squared, which is a p. The value of b is whatever's in front of the x, which is a -2. And the value of c is whatever's at the end, so that is a +3. So b squared minus 4ac is less than 0. So that means it's -2 squared, subtract 4 times a has now turned to p, c is 3, less than 0. Okay, so what we're basically doing is once we've tidied this up, we're going to be solving an equation. Okay, so -2 times -2 turns into a +4. That is going to be -4 times p times 3. So 4 times 3 is 12 times p, so minus 12p is less than 0. Now we just basically have to solve this thing. So I think the easiest thing to do at this point is to add 12p to both sides to get we want to try and keep our letter term positive. So right now it's negative, but if we move it to the other side, it's going to turn positive. So we get 4 is less than 12p for our next line. And then all we do is divide then by 12 on both sides to get our value of p. So that's going to be 4 divided by 12 is less than p. What is this fraction simplified? Divide top and bottom by 4. That's going to be 1/3 is less than p. So the range of values that make this quadratic have no real roots, basically p has to be any number greater than 1/3. So 1/3 is less than p, or if you want you can flip it round, but just make sure to change the sign. If you do that, the gap should be at the p. So p is greater than 1/3. So the range of values are p is greater than 1/3. So any number bigger than 1/3 makes this quadratic have no real roots. And that's how we do that question. So it is subtly different, the two types of questions like we were doing yesterday, which is just state the nature of the roots. So find the discriminant, state the nature of the roots, right? So that's meaning we don't know what the quadratic roots are. We have to find the discriminant and then state what that means. Well, this is kind of doing in reverse. This is saying, right, you know the nature of the roots, it has no real roots, but I don't know one of my values for a, b, and c. So using that knowledge that no real roots means b squared minus 4ac is less than 0, solve an equation to find that missing letter p. Okay, so that's typical past paper question for quadratics discriminant. What we're going to do, which is slightly easier, is this past paper question, which is completing the square. Okay, so write this down. This is our next question, and I didn't see many of your work. You didn't send me most of your work, so I'm not totally sure how you got on with this yesterday. But from what I did see, it was good. Nobody asked me any questions, said to tell me they were stuck. So, or one person asked me a question. So I take it from that everyone else was having success. So we'll do this question, and this is just kind of further practice. So we've got x squared minus 6x minus 81. So we're changing it from a trinomial form or expanded form into this completed square form. Okay, so we're just using that process for completing the square that we learned yesterday. So I'll continue to say it the way I think about it. You just focus on the first two terms. You kind of ignore the minus 81. They're going to go in a bracket. You take an x off both things and you half the number. So x squared turns to x, take an x off that and half that number. So that's going to be minus 3. And that is squared. Don't forget to put that as a bracket squared. It should look exactly like this, at the end, just with p and q as numbers. So we've got x minus 3 squared. Then I take away whatever this number is and square it. And then I bring down that minus 81. Okay, x minus 3 squared, that now doesn't change. I just need to tidy up this number out here. So that is minus the value of 3 squared, so minus 9, minus 81. So x minus 3 squared, minus 9, take away another 81. That's going to be minus 90. And that is you finished. I don't think those are too bad, really. Okay, so what we're going to do now is some more practice on